Go ahead and call this meeting of the Jefferson County Water Authority to order. Roll call, please.
Terry Thomas.
Present.
Matt Unrein.
Here.
Greg Camp.
Here.
Kevin Dennis.
Here.
Jim Caston.
Here.
Mark Johnson.
All right. Would everyone please stand for the Pledge of Allegiance? Pledge allegiance to the flag of the United States of America, to the republic
for which it stands, one nation, under God, indivisible, liberty, and justice for all.
All right. Thank you all. We have minutes from the regular board meeting of March 18th. Would entertain a motion to approve the minutes.
Motion. Second.
Made and seconded. All those in favor signify by saying aye.
Aye.
Any opposed? Hearing none, minutes are approved. Item 5, approval of bills. If you have the updated agenda from Michelle, included another $6,966.69 for a total of $217,627.03. Any questions? If not, then would entertain a motion to approve the bills.
So moved. Second.
Roll call, please.
Terry Thomas.
Yes.
Matt Unrein.
Aye.
Greg Camp.
Yes.
Kevin Dennis.
Yes.
Jim Caston.
Yes, ma'am.
Mark Johnson.
All right. Item 6 on the agenda is old business, a summary. We have Luca DeAngelis from Burns and McDonnell on the call with us. We also have Martin and Becky from Steeple, who are, of course, handling the financial side of things. Also, they can get the update. But I know Luca, I think, has some good news for us as far as how the test well went. Luca, go ahead.
I do. Let me see if I can try to share screen. So this is the part that it says host as disabled participant screen sharing. Do you guys have that?
Get you to do that. I'm going to make you the host for a minute.
What?
Okay.
Okay. Hello.
Mark is on his way. He's on Main Street in Festus, Laura just said.
All right. Looks like I can share a screen. Let me know when you guys can see all that.
I'm good here.
Okay,
Yes.
perfect. Yep. So like Greg said, we do have some, generally good news. So I have 10 or 15 slides. I'll try to go through them relatively quickly so I don't take up everybody's time. But wanted to give you guys a quick recap of both the work that we did before and then more importantly, the work that was just recently completed out in the field. And that was the test drilling of the new potential collector well site. So what I wanted to go through today was some of the work that we did before, which is the modeling that was done for horizontal collector well number 2 site. And so, if you guys remember, we talked about that, I think in December and January. Essentially, it was using all of the data that Jamie had provided to us, including 2 aquifer pumping tests and all of that information, building a computer model with that, and then using that to predict yields for the new collector well at different kinds of river conditions, high flow, low flow, average flow. So we did that. I'm going to talk just very briefly about those results to kind of refresh everybody's memory. Get into the test drilling after that. Obviously, when those results, we update the well yield and then give you guys kind of at the end an estimate on our schedule in terms of delivering a report and then, kind of what comes next. So I just flashed page 2. Did that work for everybody?
Mhm.
All right, perfect. All right, so I just want to talk real quick about the modeling. We calibrated the models to 2 different aquifer tests, so we had a lot of data available. One of those pumping tests was the pumping test that was done right after the collector well was built in 2003. Both of these tests were 72 hours. That test was done during pretty low river conditions and really cold river conditions, so low recharge. Then the second test that we had was done in 2014. That was high river stage, high recharge. So we had 2 different events, calibrated all that, brought in all the information on geology that we had, and again, kind of tested some different lateral configurations and then ultimately used that tool to estimate yield. This is kind of what we looked at in terms of here's your existing collector well. And then we tried a couple of different shapes and patterns for collector wells in the model, and this is kind of what we ended up with. The distance between those is between 700 to 1,000 feet, depending on how you measure it out. And one of the things that we decided to do for this one was to keep the caisson a little bit further inland than the existing one is, to minimize or eliminate the impact of scour. As you guys know, this scoured out, so we fixed that, but we want to kind of not have that problem with this second well. So that's how we set it up. We looked at different river stage conditions. In terms of our modeling estimates, we looked at averages, and then we looked at what we call 90% exceedance low flows. So those are very low flows, 70,000 CFS in St. Louis. But we looked at these two different river conditions, what I would call as average and what I would call 90% exceedance. We also looked at some really low flow conditions, if you guys remember back, but put all that together, and this is kind of what we came up with. So different profiles of the collector well. And at average river stage, we were in the high threes in terms of million gallons per day of production. And at pretty low river stage, 90% exceedance, we are just above 2 MGD. So those two, that's kind of our operating range. Higher flows in the river, you're going to get higher yields from the well, but anywhere between 2 and high threes was kind of what we were looking at. And then just to remind, when I say exceedance, like 90% exceedance, what that means is that over the historical record of a stream flow gauge, that stream flow that we're modeling was exceeded 90% of the time. So it tells us very low flow. So kind of forgot to bring that up. But so that's where we were at before, was 2 to high threes for the new collector well. And then we also looked at a scenario where during a really low condition in the river, you might have to operate both wells at the same time to try to figure out how much total production you can get from both wells. Here, what we're concerned about is the wells kind of interfering with one another and the drawdown overlapping. So we talked to Jamie, and 1 MGD seemed to be like a reasonable number to assume for the existing collector well at a lower flow. And then using our 2 to 2.2 MGD, we pumped those two together to see if it was sustainable, and it was. So what this does is, if you add this, then you're essentially going from, during a drought, 1 MGD to as much as 3 to 3.2 MGD. So that's just kind of a quick recap of what we did before. We sat down and talked about it and said, do these numbers make sense? And the board said, yes, they do. Let's move to the next step of the project, which was the test drilling. And so that's what I want to talk about today, but I did want to kind of recap what we did before. So test drilling, here's what we did, right? So we've got the existing collector well, and then we're just about 1,000 feet to the south, still in the floodplain and the tree line and stuff. But this is that shape from before that we modeled, and this is approximately where the 3 borings that we drilled were drilled. So what we did was three geotechnical borings. They were drilled and then converted into 6-inch diameter temporary wells. And what that lets us do is put in a 4-inch diameter submersible pump. So we can pump those wells at anywhere from 100 to just a little bit over 300 gallons a minute, get really good information on capacity of those wells. That tells us more than the capacity of those test wells, which, I don't care about that much. What I care about is what the information gives me to tell about the aquifer. And our objective here was to look at, does the aquifer look the same as what we have at the existing collector well? Does it look better? Does it look worse? Let's try to figure that out. So that all helps us with that. At the end of 2 of those tests, for 2 out of 3 of the wells, we collected off-site laboratory analytical samples. And so those are, some of those results have come in, but those are for all regulated parameters. So it's everything that you guys have to comply with that is in a CCR. From a certified laboratory. So in addition to that, Jamie also ran a lab sample at the JCWA lab to get a feel for iron, manganese, TDS, alkalinity that you guys just talked about, right? Stuff like that. So we have that data. That's the lab data is trickling in. We have most of it. I don't have all of it yet, but it's mostly here. And then again, trying to make sure that, in the model, we had assumed that the geology would be as good as it is at the existing collector well. We wanted to make sure that assumption was correct. And then if it's better, let's figure that out, or let's factor that in. If it's worse, let's figure that out and let's factor that in. So that's kind of what we did. And this is how we did it. So who we used was Trout Drilling Company. So it's a contractor that I've got about 24, 23 years of water supply experience. I've used them since the early 2000s. They're out of Minnesota, so they're kind of they don't come down to Missouri as often as I would like to see them down here, but they're a very good contractor. Not only do they do this kind of geotechnical drilling, this is very specialized, geotech water supply drilling. They also drill big production wells, so they're a really good contractor. They came out with this track mounted unit that is great for tough to get to sites like what we've got down at the site in the floodplain, right? So the benefit of this tool is it does continuous soil cores. So what you get in terms of quality of samples looks like this, right? So this is a picture, hopefully you guys can kind of see it, of boring number 1. So this is the boring that was furthest to the north. And, we start here. This is depth 0, 5, 10, 15, right? So we got all these little placards. And, you don't have to be a geologist necessarily to be able to tell that there's, sand and gravel starting from 40 all the way down to about 65 feet. And then there's a bunch of silty clay stuff above that, right? And this stuff down here in 65 that looks different is bedrock. So the reason we selected that and recommended that drilling method is it produces this kind of a core. It's essentially continuous. We don't have a lot of slough or zones that we miss. So we've got a near continuous core, gives us really good information. And in general, the geology is, like I explained, 0 to 40 feet, silty clay stuff, sand and medium to coarse sand and gravel 40 to 65 feet. That's where the water is produced out of this aquifer. So we want to see as much of that as we can. And then bedrock is 65 feet. So and how does that compare back to the existing well? It's pretty comparable. The sands here are a little bit better, maybe a little bit thicker, but it's comparable. So I'll make a comparison of all 3 borings at the end, but that's the first one. This is boring number 2. So I'm going kind of north to south. This is the one in the middle. So for this one, it's a little bit deeper, and I've got 2 photographs. I've got the same information, 0, 5, again, all placarded in. So you can see this one ends at 50 feet and then kind of continues over here, goes all the way down to about 73 feet. So what we've wound up seeing here was similar, 0 to 40 feet of clay and silt, sand to coarse sand all the way down past 60 feet. And then they got into some finer grain materials that really aren't water bearing. So that's the material that, at the existing collector well, we have 2 different elevations of laterals. We've got a higher elevation that produces a lot of water and a lower elevation that doesn't produce as much. The ones that are at that lower elevation are kind of screened in this material. So we're trying to really focus in on this highlighted yellow zone, and it's essentially, again, 40 to 60, 65 feet at the site. And then 3, same type of stuff. This is the one that's furthest to the south, and we have actually a little bit less clay here and a little bit coarser sand and gravel materials. So that's good to hear. So this goes all the way down to 63 feet, where we go basically 30 feet to 63 feet, where we have sand and gravel material, water bearing, geology that's favorable for us. And then below that, we have, actual wood. So, people are always amazed when we're drilling in these floodplains, but you actually pull up old trees. That's what we pulled up here at about 63 feet. So we have a layer of organics and wood that we don't really want to get into in bedrock at 66 feet. If anybody is a rock geek, it's a St. Peter sandstone as our bedrock. It's also what you guys see when you kind of go down that road to get down to the collector well site. So, that's the geology that we saw. And so it's good geology. And at the end of the presentation, I'll do a comparison, but it's at least as good, if not better, than the borings that were drilled at the existing collector well site. So we have somewhere between 25 and 30 feet of sand and gravel material that we can use as our aquifer for a new collector well. And that compares pretty favorably to the existing collector well site. So that's kind of the first phase of each one of these borings. And so we do the boring and the pump test sequentially at each site, and then we move to another site. So the first part is drilling the boring. The second part is doing the pumping test. If you guys have any questions as I'm going along, just feel free to chime in. But this is the rig that you saw, right? And the well here is over here, and they kind of route the discharge over this way. But we install this pump. This is a submersible pump capable of doing almost 500 gallons a minute in the right environment. And then you got the motor down here that goes inside the 6-inch well. We have a water level indicator, which is this tape. We have this blue thing, which is a pressure transducer. So that actually measures water level change and records that change electronically. So then we can download it to a computer later on. They've got a flow meter and a pressure gauge, so we can look at the discharge pressure and the discharge flow rate. So what we really want to know is the flow rate and then the water level. So that's how we measure and monitor all this stuff when we're out in the field. And then once the field work is over with and it comes into the office, then I can look at the data and try to make some sense out of it. And so this is a plot of that data. So we collect this information. It's about a 4 to 5 hour pump test. And we do different rates. So we start off at 100, then 150, then 200, 250, and then whatever it maxed out at, which is about 320 gallons per minute. And so that's the max of the pump in the well, not the aquifer. But our objective here is start rates low, go high, and then calculate specific capacity. And so that is gallons per minute per foot of drawdown. So you can see the drawdown over here on the left, and the GPM is over this area. So, you know, for example, here, this is about 50 gallons per minute per foot of drawdown. And then I can use that information, relate it back to the properties of the aquifer, and then compare them to what we use in the modeling, compare them to what we tested in those 72-hour pump tests at the collector well. And then, you know, based on that comparison, I can tell you relatively, is this a better site? Is it a worse site? Is it the same kind of site? And so here's a comparison of what we saw. We did the 3 pump tests at each of the different boring locations, right? This is just a little bit of information about what we screened and how we screened it. We mostly screened 20 feet of that sand and gravel. That's what the contractor had on site, was a 20-foot long screen. It's built the same way as any vertical well would be, with wire wrap and stuff like that. So it's a pretty efficient well. We started 100 gallons per minute on each of them, and then we went basically to 320 or 330 gallons per minute. 320 or 330 gallons per minute at each site. And then I highlighted the GPM per foot of drawdown in terms of what specific capacity is. So our best site is boring 1. Our other 2 sites are very comparable. So, but in general, anywhere between 20 and 50 gallons per minute compares very favorably to the specific capacities that we saw during testing of that initial collector well. I also put some information here about the actual collector well itself, right? So when it was first built, it was operating at 100 gallons per minute per foot of drawdown at 3 million gallons per day. Currently, it's around 26 GPM at 1.5 MGD, and that's stuff that Jamie texted me yesterday. So just to kind of give you a relative comparison. Now, you can't really compare a specific capacity from one well to another like that, just looking at the numbers, because it is impacted by the efficiency of the well. So a newer well will have a higher specific capacity than an older well. But what we can do is we can relate it back to aquifer properties. And so this, when you get into the, you know, hydrogeology geeky world, this is what we're really interested in, is what is the transmissivity of the aquifer. Transmissivity is essentially how easy water moves in and out of the aquifer. So the higher that number is, the better it is for production well yield and collector well yield. So our range was anywhere from low 50s to as high as 80,000 gallons per day per foot. What was calculated from the pumping tests of the collector well, those are 2 72-hour tests, was between 50 and 60. So we are right there in terms of our estimated transmissivity, which that's probably the most important parameter in the aquifer that dictates yield. So the geology is very similar. The depths are very similar. The materials are similar, if not slightly better. And, you know, the transmissivity looks to be as good, maybe just a little bit better than the existing site. So far, all the info looks real good, right? So I'm a direct comparison between, you know, our existing collector well, your existing collector well, and then this potentially new site, right? So it kind of gave you the rundown transmissivity in those 2 72-hour tests. So, you know, the one that was done in 2003 and the one that was done in 2014, this is the range, right? I go back a step, and this was our range from our short-term test, right? So we are right in that range, if not a bit higher in general. So that's all good. Our material at the site, that we tested was, you know, generally we have 3 borings. I'm kind of taking a spitball average here is between 40 and 65 feet was our depth for our sand and gravel material. At the existing site, you had 49 to 65. So basically 50 to 65 feet of sand and gravel. And below that, there's some finer materials. So I think we have more sand and gravel at this site that we can work with, allows us to maybe set some of those laterals as deep or deeper and not have to worry about having laterals that don't produce as much. Bedrock was at 73 feet, and you kind of saw our bedrock was typically at around 65 feet. So that's a little shallower, but this is a bit misleading because that 65 to 73 feet is filled with junk, silt clay, fine sand, stuff that really doesn't yield a lot of water. So that's also kind of functionally equivalent. So, you know, the big deal here, conclusion, geology is as good as better at the second site as it is at the first site. So that means, you know, all of the assumptions that we had in the modeling are still valid. When we do a direct comparison in terms of what you had at the existing well, that's still valid. So, you know, what does it all mean at the end? We look at kind of design considerations. At our potentially new site, Collector Well 2, grade is 390 feet, 95 feet above mean sea level, right? So we were talking about a depth of 65 feet to bedrock. So I think the maximum depth for laterals would be 55 to 60 feet. And these are numbers that I think Jamie's probably interested because he can directly compare them back. But a preliminary lateral elevation design would probably be 340 to 335. And so I put the collector well case on your existing collector well on this slide just for a comparison. So you have one set of laterals at 338. Those are the more productive ones. And then one set of laterals at 334. So what we can do, we're in that same zone, which allows us to have just as much drawdown as we have at that existing collector well, but we don't have that lower fine grained material here as much. So as long as we avoid that, we can kind of keep the laterals at this elevation 340 to 335.
Hey, Luca.
Uh-huh.
In regards to that, just to make sure some of us that are clear as far as the existing problems with the old collector well versus what we have now. The biggest problem with the existing collector well is the bottom three laterals are our biggest problem. They don't do much for production. So our biggest key factor with this project is making sure we get the laterals at the proper elevation.
Right.
Otherwise, we'll have the existing problem that we have. Because the bottom three don't hardly produce not much at all.
Right.
Just top two, 5 and 6 produce almost everything. So in theory, if we do get it at the proper elevation, that means this new collector well could produce an exorbitant amount more.
Yeah, it can produce more and more efficiently for sure.
Right. And on top of that, as far as our vertical test wells that, you know, we just recently did, in theory, as far as since you are extending the laterals out, it could possibly, since it's spread out, produce even more than that, considering its longer distances.
Yeah, for sure. So that's what we take all the information that we get in that testing, and then we convert it over to all the hydrogeo terms that you heard me kind of spew, transmissivity and stuff like that. That allows me to do the calculations to then figure out what's going to happen when we make those lateral screens long and horizontal instead of, you know, relatively short and vertical. So those are great points, Jamie.
Yeah, I just wanted to make sure, you know, in other words, if there was worries as far as this one being, you know, us moving forward on this one and building this one, that we most definitely won't have the same issues with the
right
one. I'm assuming all the laterals on this new one would all be at the same elevation and not two different tiers.
Correct. Yeah. Normally, the only time you do 2 tiers is if you have a really high producing well. Sometimes collector wells, if they're in the right environment with both the river and the geology, they can make 15, 20 million gallons per day. And that's when you typically see 2 tiers, and that's just to get the water into the well a little bit more effectively. You don't normally see 2 tiers. So we would have just 1 tier of laterals. The reason there's 2 tiers of laterals out here is that, go back one slide, there's this unit here, this fine sand, silt, clay stuff that's below 65 feet. We didn't really see that much here. And all of our exploration, you know, we're going to wind up staying above that. So we avoid this problem. So yes, Jamie, we're going to be one tier of laterals, all set in sand and gravel, but similar elevation to what you've got right now. So the drawdown that you have available will be comparable. So I answer your question?
Yes.
All right. Any other questions? All right, so this is what where the drum roll occurs, I guess. I should have done the drum roll beforehand, but this is essentially an output of a spreadsheet that I have that does collector well yield. There's a very big fancy algebraic equation that has a bunch of parameters that go in it, but the main parameters that go in are aquifer transmissivity, which is what we talked about calculating, and then distance to the recharge boundary, which is the river. So once you get those things dialed in, then you can do some estimates based on the variability of the river stage at your site, right? So what I did here was I've got what we normally do in projecting collector well yields is we look at kind of a couple different conditions. We do summer and winter, and the reason that we do that is even though you wouldn't think water's viscosity changes that much with temperature, it does a little bit, and that impacts hydraulic conductivity, aquifer transmissivity. So it reduces the amount of recharge. And so the colder it gets, the more viscous it is, and the less recharge we get. So we want to look at that as a winter. A lot of times is when we'll get less flow from our well than in the summer, which is good because that's when there's a lower demand. But in the summer, you have kind of the opposite where it's less viscous, it's warmer water. And so we have a higher transmissivity or higher recharge capacity. So we want to look at that. But we also, you guys are next to a really dynamic river. The river goes up and down. We were at flood stage or, maybe slightly above flood stage before we mobilized for the test drilling, and then had to, do our, cross our fingers and hope we didn't get any additional flooding, right? So to get out and, we're not as concerned about that because when the water is up really high, you get higher flows out of the well, but we want to at least look at average conditions. And so that's what these are. You got a winter condition at average and a summer condition at average river stage. And so this river stage is dialed into you guys's collector well site. We were able to do some pretty good surveying as part of the scour hole repair. So we have actual water level measurements, or I guess not water level, river level measurements, tied into the gauge at St. Louis. So when it's a certain flow at St. Louis, we know the stage at your location. And then we also did the same thing for 90% exceedance, so much lower river stage. And so that is about a 7-foot, 8-foot difference in river stage, which is just 7 or 8 feet of difference in production capacity that Jamie has. So going to go back to that specific capacity. If you've got, this 7-8 feet is 7-8 feet less of drawdown. So when the well was new, it was 100 gallons per minute per foot of drawdown. That's 700 to 800 feet of capacity you just lose because the river dropped, right? So we want to make sure we're looking at both of those, and we did. And so what we come up with was a range of about 3.5 million gallons per day to about 2 million gallons per day in the wintertime. So this is really low flow and cold. So this is very very bad recharge conditions for the well. We think it's 2 million gallons per day. That is similar to or maybe better than the well when it was tested, the existing well when it was tested, and then 3.5 MGD at the high end. So this all kind of falls right into what we talked about with the well yield before. There's a decent amount of conservatism built into these calculations, so we want to make sure that we're conservative. We're using, you can kind of see the T value. This is transmissivity. That's 54,000 using this calculation. Our range was between low 50 to as high as 80. If we were looking at what was at the existing well, it would be 50 to probably mid 60s. So if the transmissivity is a little bit higher, these yields go up a little bit. We used a pretty conservative distance to the river boundary. It's possible we'll scooch the river, or we'll scooch the caisson a little bit closer to the river. That comes down. If that comes down and transmissivity is actually a little higher, these numbers go up. But I wanted to present conservative numbers to you guys. And again, they tie into basically what we had for the modeling. I'm pretty confident that this is the range that we're getting into. Kind of 2 during low river conditions and cold river conditions, 3.5 to 4 during high river conditions or average river conditions, and in the summer. So how does that pair back to the modeling? Again, this is the slide from the modeling that showed, low 2s to high 3s, just a analytical check on what we did based on the test drilling results. It's essentially the same number. So that's it for you guys. Before we get into like what's the next step, you guys have any questions on what I presented so far?
Yeah, I have one. You're saying you're seeing a lot of similarities between your new site and the existing site.
Right.
And, you know, Jamie has to shut the wells down because it don't even produce enough water whenever it's in a negative or even what, 8 feet at the each bridge, you're having to shut down because there's not enough water. I mean, and you're saying we can 2 million gallons a day at like that stage?
Well, and that's what when we were talking about as far as the problem with the existing collector well is the bottom 3 basically don't produce. So your top 2, if we get this correct and in the proper elevation as far as the material, it will produce even more than what our existing collector well does because all your lower laterals were punched in the wrong formation.
Right.
The other thing is me and Luca discussed about its possibility. Of course, you know, there would be a little bit more research. We could possibly put the very tips of these just out towards the river. We could increase the lateral lengths longer than what we are instead of having all these shorter variations. We could all make them 200 something foot out on each one instead of having this cluster of everything.
Yeah, my biggest thing is I want to make sure that if we're going to go with this, we're going to not have to tell the cities, hey, you've got to turn your well.
Well,
If we have 2 collector wells, there should be absolutely no reason the city should ever have to run wells except for maintenance at the plant.
Yeah, other than maintenance at the plant. Yeah. Yeah.
Right.
If the clear cone's being refurbed,
Yeah,
then
that's my biggest thing. I want to make sure that we don't have to, in the middle of summertime, tell the cities,
right.
you've got to turn your wells on because there's not enough water in the river.
Right. Well, the other thing is there's a positive to this on top of it. I mean, there will be the redundancy factor on top of it. Let's say we got to extremely low negative numbers. Since one collector well has its set of laterals out in the Mississippi River and the other ones are more inland, it has less of a factor to sit there and influence one another. So both could run at the same time.
Luca, you touched on that briefly, the ability for both collector wells to operate and feed the plant at the same time. I mean, that's something that's doable, right?
Yes, it is. Yep. So we looked at that in terms of interference between the 2 collector wells and at a very low river stage. And you can do that. Yes. So we were looking at, you know, that's when the lower number on this current collector well comes into play. So you're probably talking about in the 2s for MGD supply from the new one, and then 1 from the existing one. So you're still talking 3.5 MGD or so during really low flows in the river, and meeting your summer demands that way. So yes, you can do that. So it does provide, so the things that it does, I mean, if you added a second source, obviously, if there's a problem with one of the wells or a pump, that doesn't take the well, you know, you've still got a supply, right? If you can take one out of service and work on the other one, and not lose your source. So that's a pretty big deal. The other thing that would be important is like the yield of any well, doesn't matter if it's a collector well or a conventional well, is always highest when it's brand new. So it's important to get the well on a maintenance program that is, you know, repeated and sustained, and, you know, whether that's once a year, once every 2 years, once every couple of years, you know, data driven, you know, however you want to do it. Some utilities look at the capacity changes in the well and then they call out a contractor to clean it, or some do it on a regular frequency. But that's probably the most important thing to making sure that it, you know, whatever the yield was when it was installed, that it stays as close to that as possible, because all wells are the same. They all sort of, they start to degrade from the get-go and their capacity goes down. But if you clean them, you can keep them up. So that would be an important thing, so that you make sure that, you know, 5-10 years down the road, the yield is pretty close to what it was when it was installed.
What's the life expectancy of a well? One that's maintained, and, you know, I understand we maintain ours pretty good.
Right. I'd say so design capacity is probably 15 to 20 years, and then life capacity is 20 to 50. So when I say that, what I mean is if you maintain it, design capacity, you can keep that 15 to 20 years, or it'll still operate as it was at the beginning, yield wise. And then between that 20 to 50, it's still functional. It still works. It might not have the same exact yield as it did before, but it'll still have value, right? And then after 50 years, some of the materials start to the steel and stuff becomes more difficult to maintain long term. So that's pretty generally how I describe it, though.
So the new well, you've made several engineering changes that
Right.
have improved with your drilling and everything. So we should expect a decent out of that one and still get a little bit out of the old well.
Yeah, that other well still has life to it for sure.
Okay.
So it's still got life to it, and you guys are maintaining it. So some communities don't really put a lot of effort into maintenance that you guys do. So as long as you keep maintaining it, it'll keep, operating at that 1 MGD, maybe a little bit 1.5 MGD or something like that. And then, this one, when if you build a new one, then just get it on a similar sequence and keep the specific capacity as high as you can. And that'll keep your design yield at about, comparable to what it was when it was built. So any other questions?
Yeah, I've got one about future demand. Have you done any modeling since Festus and Herky got homes popping up like weeds? Does the MGD that you're forecasting, will it keep up with our 20-year demand?
So we have not been tasked with doing like a master plan to look at demands. It's a good idea, but that's not been part of our study.
What, Jamie, what's our demand between both cities right now, average daily?
Right now it's about 1.4. In the summer months, it'll get closer and closer to 2. But if you're concerned with as far as future demand, and we have both let's say we have both collector wells, there is another solution to avoid spending a ton of money to build even a third collector well. You do have the option to punch more laterals into either one of these collector wells, because that was in the past, that was something we had looked at, but it would sit there and gain us enough for future expansion.
Okay, well, that might be something we want to look at. We've got these subdivisions coming in, and folks that want to annex, we perhaps may want to look at whether or not we can actually serve them water.
Well, the bigger issue would be if a Doe Run or somebody like that came back that was using 200,000 gallons a day, just themselves. That's equivalent to, I don't know what, 1,000 homes. So just one manufacturer could turn the whole thing upside down.
Right.
And I think it's important to notice, and it's part of what Mark was talking about. We don't have any redundancy in the system, right? The redundancy in the system are the city wells. And we know what a disruption switching from different aquifers and the different types of water can cause to both cities. So I think having that redundancy, but when you're looking at these numbers, I'm thrilled with what we're seeing here as the possibility of a yield out of the second collector well, because you're talking about more than doubling our current capacity, or at least our ability to pump water, pretty much as the plant can handle right now.
Right. Yeah, I think when you think redundancy, if you go forwards with this, then you do have real redundancy in your source water. Just having one, I don't know that I would even consider in an ideal setting the bedrock wells, the city wells, as redundant. I'm like, you should keep those, right? Even if you build this collector well, hopefully not have to run them ever. But there's a lot of communities that have bedrock wells that they keep as backup, and those are just like, maybe peak shaving, but most of the time just really backup. Like, hey, we lost our plant, or hey, we lost our source water for whatever reason. Now, if you have two collector wells,
Lightning storm.
Right, exactly. Lightning storm, right. So it's very unlikely if you got two collector wells that you'd lose both of them, right? But you could lose the plant, lightning strike, somebody takes a water main out or something like that, right? You would still keep those, and those would be just backup. They're just not even, I wouldn't even think of them as redundant anymore. Your redundancy becomes the two collector wells. Those wells are built with redundant pumps in them. So you have, if you have a pump failure at the well, that doesn't take the well out. So you'd have redundancy in the pumps, redundancy in the supply. And then this backup that not all communities really have. And then all of a sudden it's very appealing, right? Because you can handle a couple of different situations, including the loss of your plant if, God forbid that should happen, which you can. So, but yeah, that's what we found. If you guys are interested in having us taking a look at projections, we certainly can. That's not something that I necessarily do, but that's something that we do as a water group within Burns McDonnell. And there's some pretty quick and dirty ways to do that, and then there's certainly much more elaborate, planning ways to do that as well. So if you want us to take a look at it, we can. But it's not something that we've done necessarily just yet.
What's your thought on that, Jamie, to do some sort of study for future growth? And like Jim brought up, didn't even think if somebody takes over the old St. Joe site, there'll be more industry needing water. That's something we need to look into.
Well, that's the thing is to be perfectly honest, the plant's only rated for 3 million. So if you get anything above that, the plant has to expand it. So you'd have to do a ton of studies during that period of time to do it if you were going to do that. But you would go through the extent of 4 filters, another cone, or Clarewell storage and everything else when you get to that.
Right.
So I'm limited as I am. So if we get to that point, then we could probably go ahead and do the study, because otherwise it's kind of a moot point now.
Right. I could see at some point where you're going to have to expand the plant, I think.
I want to do that.
And Kevin, I'll be honest with you. I mean, we're not at the capacity of the plant yet.
No.
But we certainly can see what's happening around us with
Right.
Matt alluded to as far as the number of houses that are popping up out of the ground.
Right.
I had a call earlier this morning with a developer that, if something like that comes to fruition, you're talking about a substantial increase. But what this does is it gives us at least the capacity on site,
yes,
to max out the plant.
Right.
And then if we're above 3 million a day, then we know, we've got a bigger issue. But we don't have the ability to max out the plant right now.
No.
Based on the current ability of the current collector well.
I've always wanted to.
Well, I mean, okay.
I've always wanted to, though.
Okay.
Now, I mean, that's the thing is I can talk to DNR and see whether we can get the plant re-rated or see what my new configurations would be to push the limit to 4 million gallons a day.
That's
So
kind
you
of
have to re-rate. Yeah, you got to re-rate your filters to do that, right?
Ask them ahead of time and get ideas, not that we'll actually do anything.
what was that, Luca?
You'd have to re-rate your filters to do that, right?
Yeah.
Well, each one of those has a rating of almost 4 million gallons each.
Okay.
Yeah. It's always good to be proactive. Sounds like you've already thought about it, Jamie.
Sure. Like on the planning side, so what we do for a lot of utilities is master planning. So master planning typically looks out 20 years on your demands, and sometimes can look out as far ahead as 50 years for supply. Most of the time it's 20, but it actually looks at, and like Jim said, we project out populations, but then if you think that that there's an industry, then you try to plan for that, or maybe you just kind of leave some amount of reserve. But what that does is if you identify, water deficits, it allows you to basically develop a capital improvement project plan. So you're kind of listing out of, hey, we, in 10 years, we think we're going to need additional source water. In 15 years, we're going to need to expand our plant. In 20 years, we're going to need a new plant. We need more storage, all that kind of stuff. Those can be, pretty elaborate, but we can also look at demands in different ways. And then, yeah, Jamie, if you start looking at the rating of the plant, give me a call. I'll probably have some ideas there.
Absolutely.
All right. So what we have next in terms of and this is my last slide. So what we have next in terms of schedule. So we're essentially done with the first 2 phases of work that were part of our design build process. And what I'm doing right now is I'm working on a report. So we'll have a nice report that summarizes the modeling I talked about, summarizes the investigation I talked about. We'll include the results of the water quality that I talked about. And so you'll have 2 samples from a certified lab that go through, all of the regulated parameters, VOCs, SVOCs, pesticides, herbicides, metals, all that kind of stuff. We'll have all of that in there, so you know what's in your source water. And Jamie's already analyzed that as a lab and knows that the water's in good quality and treatable. I also have some geotech lab results that I'm waiting on that isn't that big of a deal to you guys, but it's stuff that I use to back check my estimates of transmissivity. And so I'm waiting on that, but all of that stuff's going to be in the near future, and I will have the report, Q reviewed or quality reviewed internally, and then sent out to you guys no later than the 26th, so that you guys have some time to take a look at it. I think it'd be a good idea for me to come down and visit with you personally after that, if you have any questions. If you don't, then we don't need to, but I can come down and kind of talk through it if you want. Sort of on a parallel path, we are working on the design build agreement, which is going to detail scope and estimated fee for the 30% design. And so that would take all of the information that I have. We got a 3 to 4 MGD collector well that we have to design for the big side, right? We'll design that, and then that includes Lane, which is our sub for the below grade, and Alberici, which is our sub for the above grade, all of their input, and then permitting, and then development of a GMP. We should have that to you guys early to mid-May, and then if that all looks good, then we move forwards with the project, and if it doesn't, then we don't. But if we do, then we'll start working on it in May, June, somewhere in that time frame, and get rolling on the 30%. And I think that's all I had, and I know you guys had some questions, so do you have any more?
Yeah, I was just going to say, Luca, we have Martin and Becky with Steeple on the call. If they had any questions, I asked them to join us, just because them being up to date on the timeline is important. I don't know, either of you had any questions for Luca or?
No, this is really helpful. This is Martin. Thanks for the invitation. Let me listen in. This is really helpful. I think one of the big questions we had was, is the site a viable site? So that's why we needed to kind of pump the brakes on the financing, just to make sure we went through this test drilling to make sure that this is a good site for the project. Right. So this absolutely answered that question for inviting us, letting us sit in and listen to this. I think, based on what I'm hearing, it sounds like we probably need to go ahead and start thinking about picking up the schedule and moving the bond portion forward again, unless you feel differently. I think that, if we're based on what you said, Luca, as far as your, next step is going to be the design build. And if you can get there, ideally closer towards the beginning of May from our perspective would be great. Sure. But, maybe if we have the agreement, executed by like May 15, I think, as far as like maybe a drop dead, that would be ideal, just so that we could include that language and that fact in our bond documents to give a little more credence to, the process and where things are, and kind of mitigate some risk in that regard.
I'll make sure that I have, a design build group that will help me with that, and I'll make sure that they know that that's the date. So, and I'd already communicated that based on our previous previous call. I kind of gave them that, so they've been working on it. I don't think that's going to be that shouldn't be an issue for us. So we'll charge ahead with those dates in mind.
Okay. So really, Greg and gang, if you guys are okay, we may start working up a new schedule again, and then Greg, I'll just coordinate with you and share this draft with you, or maybe I'll check in with you maybe later today, this afternoon or so, and just kind of give you some thoughts that I had in that regard, and see if that timing and stuff seems to match with what you're thinking. That's
fine, Martin, and I'll make sure we circulate anything as far as a draft of the group, and if they have any questions, we can either they can direct them to me or and then we can get answers for everybody as we move along. But I think, getting the timetable updated so that we know what fence posts we got to hit and when we got to hit them by is important.
Okay. Hey, Greg, we need to get Cochran/Carl down there to, give us this, I guess, spot survey or corner survey, and what right of way we're wanting from. Where has he done anything with that you know of?
Not that I know of, but
okay. Well, sounds like we need to get hot and heavy on that. I'll call him. And is that okay with everybody? We use them to do this? Anybody got an issue?
Yeah, if you want to call Carl and we'll need a meets and bounds types of survey.
And just let them draw it up.
Put that in Weber's hands.
Yeah. Let Cochran draw it up, the legal version of it.
That's fine.
Okay. And then my second question, and I don't know it, and I don't remember exactly how long it took, but a few years back, Mark and Jamie would know. We had all that scaling in the water line going up the hill to the plant, and we were offline for a while that happened. Do you guys remember how big a deal that was?
Oh, you're talking about the ice picking project?
Yes.
It wasn't fun.
Well,
But they don't offer ice
how long were we offline? Do you remember?
Yeah, basically.
What? I didn't hear what Mark said.
Yeah, well, basically we were offline during the day and we were able to come back online at night.
Okay, so it wasn't that big a deal. I just
No.
was wondering if we should
But there's-
consider.
Problem with that is ice picking no longer exists. So you have to go back to the old fashioned pigs ways. So that means opening up the system and everything else. So it would be more extensive this go around if we do it again.
Well, should we look at running another line up through there?
I don't think you want the cost.
Okay.
I think something Luca touched on, obviously, if we stay on top of our maintenance schedule, we're going to be good to go. But a second transmission line, Jim, is going to add a lot of cost.
Yeah, well, I agree, but if the objectives is to, the only time we are on our wells is cleaning the plant, I don't know. I'm just throwing it out there. I'm not advocating for it. I'm just, I remember it was an issue back a few years ago.
No, just temporarily.
Temporarily.
Now I can do some research and figure out different companies and get a better idea of that within the next year, see what's out there.
Options and costs.
Yeah.
Okay. All right. Does anyone have any other questions for Martin, Becky, Luca, anybody? If not, Luca, thank you so much for sharing what I consider to be good news. It's like we've got a good aquifer, a slightly better aquifer with the amount of sand and gravel that they were able to find in those test bores. So we'll proceed and hopefully have some much better news for our next meeting.
Okay. Thank you, guys. I appreciate the opportunity. We'll be in touch.
You guys don't have to hang around on our call if you don't want to. Luca, I do need you to give command of the.
Yeah. Let me see if I can figure that out. Stop sharing. Okay, stop sharing.
Okay, I think we're good.
That work?
Yes, perfect.
Okay.
Thank you, sir.
Thank you very much, guys. Have a good day.
You too.
Great. Thanks, everybody.
Let's go ahead and finish up item 7 on the agenda. New business is the Commerce Bank signature card for the investment account. You have that in your packets. We would need a motion to approve the signature card for the investment account.
So moved.
I have a motion and a second. All those in favor, say aye.
Aye.
Hey,
Any opposed? Hearing none. We'll get that signed by everybody here. In your packet is the CCR report, the water quality report. If anybody has any questions on that, that's an annual process, and we'll get that published for the public as well. But it's a good report. It's a clean report and no findings in there. Item 8, resolutions. Resolution number 2021-2020-22 is an intergovernmental agreement between the City of Festus and JCWA for vehicle maintenance services. This just gives us an option if we were so inclined to take advantage of the city mechanic in the event that he would be needed on any of the trucks or other equipment that we might have, specifically trucks and Bobcat, things of that sort. So,
Peters.
I would entertain a motion to introduce the resolution.
So moved.
Second would be required.
Second.
Now, all those in favor?
Aye.
Any opposed? All right. Will the clerk please read the resolution 2021-22 by title only?
Resolution of the Jefferson County Water Authority of Festus, Missouri, authorizing the chairman to enter into and execute a governmental cooperation agreement with the city of Festus for vehicle maintenance services, incorporating said agreement as part of resolution describing the conditions thereto and establishing an effective date.
Any discussion?
The only thing I was going to mention, Greg, is of course the city council of Festus still has to pass this same agreement.
And again, like I mentioned, it just gives me some options as far as getting stuff fixed.
And I don't see why we wouldn't pass it, Matt.
Yeah, I just wanted everybody to know that we had not done that yet.
Certainly.
If there's no other discussion, we need a motion to adopt, withdraw, table, or call for a second reading or postponement.
I'll make a motion to adopt.
All right, I need a second. Second. All right, we need a roll call vote.
Matt Unrein,
Aye.
Greg Camp,
Aye.
Kevin Dennis,
Yes.
Mark Johnson. Yes. Terry Thomas,
Yes.
Jim Caston.
Yes, ma'am.
All right. Outside of that, under reports, again, you've got your trial balance, general ledger, revenue expenditure report for information. Jamie, anything you wanted to add to your report?
Not of anything of great concern. It's been fairly quiet recently.
Don't jinx it.
What's that?
Don't jinx it.
Oh, it doesn't matter whether I say today, whether I don't. It's kind of like me and Dick at the plant say there's always manifest. We say something and oh poof, it blows up. Oh, I also wanted to thank Matt for the opportunity for the agreement and giving us an option for the plan for our needs.
Right. Anything from the board? Harry, you good? Mark?
Good. I'm happy.
Jim, Matt, Kevin?
Happy day.
I'll be up to see Jamie sometime next week, one day better than the other to
Well,
look at a few things on my list.
well, actually, Wednesday I have Chester, Illinois coming in. So the mayor, the plant manager, and a couple of their engineers are coming in because they're wanting to possibly switch to a collector well. So
Okay.
the discussion, they're going to
So
compare.
not Wednesday.
Huh?
So
Yeah.
not Wednesday.
So not Wednesday.
Yeah, it'll probably be in the afternoon. Like I said, very simple things. So I can give you a call on that. And I just a little bit behind. I still playing catch up and learning. So maybe I'll give you a call Monday and just see what your week looks like. And then I come up there for a half hour and be done with you.
Sure.
Would that work?
Oh yeah, absolutely.
All right, buddy.
See you
That's
soon.
all I have, sir.
All right. If there is nothing else, I'll entertain a motion to adjourn.
So moved.
Second?
Second.
All those in favor?